Right, we're looking at the solutions to geometric sequences and series. So question 1, part 3. In each of these geometric series or sequences, write down the value of r and the common ratio and the nth term. Okay, so first one, part 3. Common ratio is 3. The T of n formula, a bracket, r times or to the power of n minus 1. For part 4, common ratio is a half. Again, one term divided by its previous term will give you the common ratio. T of n then is a, which was a half, multiplied by r, which is a half, to the power of n minus 1. I need to tidy that up though, okay? The base numbers are the same, so I can use rules of indices to tidy it up. So it would become a half to the power of 1 plus n minus 1, which tidies up to be a half to the power of n. Everything in that bracket is being put to the power of n, so that means 1 gets put to the power of n, and 2 gets put to the power of n. But remember, 1 to the power of anything is still just 1. So I have now written my T of n formula as 1 all over 2 to the power of n. In the last one, you can't simplify that anymore. You cannot multiply the 7 by the 3 and get 21, because the 7 is not being put to the power of n minus 1. So I can't do any more with that one. Part 5. Common ratio was a half, so again, one term divided by its previous term will give you r. A was 32. So T of n equals a bracket, r, to the power of n minus 1. This can be simplified because of rules of indices. You could write 32 as a power of 2. 2 to the power of 5 is 32. Okay, everything in this little bracket is being put to the power of n minus 1. So that means 1 is being put to the power of n minus 1, which remains as 1. And then 2 is being put to the power of n minus 1. I can go further. Multiplying fractions, top by top, all over the bottom. Then it's rules of indices. Base numbers were the same, they're both 2's, they're being divided, so I can subtract the powers. So it'll be 2 to the power of 5, take away n minus 1, which will become 5 minus n plus 1. Tidy that up, 5 plus 1, 6. So you get 2 to the power of 6 minus n. So that's just fully simplifying it. Part 6, the ratio is minus 2. Again, one term divided by its previous term will give me the common ratio. A was 3, multiplied by r to the power of n minus 1. And I can't break that down any further. Question 2, part 3. Write down the first 4 terms of each of these geometric sequences given in the following nth terms. So you're just looking for term 1, 2, 3, and 4. So sub in, you'll get 20, 200, 2000, 20,000 for this one. And for part 5, you'll get 2, 6, 18, 54. Question 3. The nth term of a geometric sequence is given by the following T of n formula, where T of n equals 2 to the power of n. Write down the first 5 terms. Okay, so term 1, 2, 3, 4, and 5. Write down the common ratio. Well, one term divided by its previous term, so 4 divided by 2 is 2. Or you could have said 32 divided by 16 is 2. So the common ratio is 2. What is the difference between the 10th term and 1000? So go and get the 10th term. So T of 10 will give you back 1024. Take away 1000 from that, and the difference is 24 units. Question 4. Which of the following sequences are geometric? If they're geometric, well then one term divided by its previous term would give you a common ratio. Okay? So part 3, T of n was 1/3 to the power of n. So you could get the first 2 to 3 terms, and then you can just say term 2 divided by term 1 should give you the same answer as term 3 divided by term 2. So 1/9 divided by 1/3 will give you a third. 1/27 divided by 1/9 will give you a third. So you're getting a common ratio. One term divided by its previous term will give you the common ratio. Or you could do the general proof where you go and you get T of n minus 1, and then it would be a case of T of n divided by T of n minus 1. So T of n was 1/3 to the power of n. T of n minus 1 is 1/3 to the power of n minus 1. Rules of indices. Base numbers are the same, you can subtract the powers. Tidying that up, the n's cancel and you get a power of 1. So it's 1/3 to the power of 1, which is just 1/3. So I have proven that my common ratio is a constant. So that also proves that it's geometric. Okay. For part 4, I could do the same thing again. You could get term 1, 2, and 3. Okay. and show that the common ratio is 4 each time. Or you could do the general proof like I did with the last one, and again you'll get out a 4 when you're done. So that's how I prove it's geometric. The common ratio is a constant. And the last one, T of n is equal to n squared. So again, I want to check, is it a geometric sequence? Well, straight away, I know it's not. It's a quadratic sequence. But anyway, if you don't spot that, that's fine. Okay, you could go off, get term 1, 2, and 3. Then you could say term 2 divided by term 1 does not give you the same answer as term 3 divided by term 2. I'm not getting a common ratio. So that would define that it is not a geometric sequence. Okay, it is in fact a quadratic. Question 5, find the sum of the first 8 terms in the following sequences, or geometric series. Okay, so I'm looking for S of 8, so I put down my S of n formula. Okay, now it's actually the other way around in the log tables. S of n equaled a bracket 1 minus r to the power of n, all over 1 minus r. So don't mind this, okay, you write the way it should be written, but you'll get the same answer. Okay, a is the first term, and the common ratio, 6 divided by 2 is 3. Or you could say 18 divided by 6 is 3. So the common ratio is 3. So sub it in and you will get out 6,560. For part 5, a is the first term, which is a half. Common ratio. Term 2 divided by term 1, a quarter divided by a half will give you a common ratio there of a half. Okay, sub it into your S of n formula. Again, it's just the other way around here. Use the formula from the log tables, page 22. Sub into it and you should get out 510. Now that'll simplify as a fraction. Okay, and you actually get back 255 over 256 as your answer, or the decimal equivalent. Question 6. They give me the T of n formula for a geometric. Find term 1 and find the common ratio. Okay, so sub in term 1. Term 1 works out to be 3 all over 4096. Now, to get the common ratio, well, I know based on the T of n formula, it's a bracket r to the power of n minus 1. N happened to be 1. So the common ratio is automatically 4. But if you don't spot that, you could go and get term 2, and then term 2 divided by term 1, and you'll automatically get back a 4. But anyway, my common ratio is 4. Find the sum of the first 13 terms. So I'm looking for S of 13. So I put down my S of n formula, and I sub in. N is 13, A is the first term, which I just found there, by 1 minus r, which is 4 to the power of 13, all over 1 minus r. And you'll get back 16,383.99. It goes on forever. Don't round it. You weren't asked to. Question 8. The first 3 terms of an arithmetic sequence are x, y, and x plus y. X cannot equal 0. Obviously it can't, or wouldn't end up being an arithmetic sequence if x was 0, because your third term would end up being y, but your second term was also y, and your first term was 0. Doesn't make sense. Then 3 terms of a geometric sequence are x, y, and xy. Find the value of x and the value of y. We need to create equations. So work with the arithmetic sequence. How do you know something is arithmetic? If the difference between 2 terms is a constant, that makes it arithmetic. So term 2 take away term 1 should be the same answer as term 3 take away term 2, if it's arithmetic. So that's what I would put down first. Okay? Term 2 was y, take away term 1, which was x. It should equal term 3, which was x plus y, take away term 2, which was y. The y's here cancel, so you're just left with x. So y minus x is equal to x. Bring your x's to one side, so I'll then get y equals x plus x is 2x. That's an equation, I can't do any more with it. I'd leave it as it is. So y can be written in terms of x. Y equals 2x. Or you could have written x on its own. It doesn't really make a difference. So that's your arithmetic sequence for that one. Then the geometric was those 3 terms. How do you show something is geometric? Well, there will be a common ratio. One term divided by its previous term will give you a common ratio. So term 2 divided by term 1, which is y divided by x, should equal term 3 divided by term 2, which was xy divided by y. Okay, so that will give me the common ratio. We now have an equation. You can simplify it. The y's above and below here would divide into each other, so they're gone. So then you're just left with x is equal to y over x. Then I'd multiply both sides by x, and you'll eventually get y is equal to x squared. That's a second equation, okay, with your x's and y's in it. So basically what we're doing now, technically we're doing simultaneous equations. But if I've expressed y in terms of x, and here I've also expressed y in terms of x, y should equal y. So I can let 2x equal x squared, and we now have an equation. Okay, so we want to solve for x. Bring the 2x over and subtract it, and now it's all equal to 0. Now you have a quadratic. You can use your minus b formula to solve it, or do factorization. Highest common factor is x, a bracket x minus 2, all equal to 0. They're your two factors. Therefore, x is either equal to 1 or the bracket is equal to, x equal to 0, I should say, or the bracket equals 0. If the bracket equals 0, bring over the minus 2 and you'll get x equals 2. So I have two solutions for x, but you have to check which one of them makes sense. Remember what the first three terms were of the arithmetic sequence, okay? If x was 0, it wouldn't make sense. Your arithmetic sequence wouldn't work out. It wouldn't be arithmetic, okay? So we discount 0 and we use x equal to 2 as the only solution. Right, so if x was 2, I now need to figure out, well, what is y? So I go back to the previous equation for y. You can sub your value for x in here, or you could sub it in here. It doesn't matter which one you pick. Okay, so if I just sub it into that one, if x is 2, then y is 4. Okay, I can then write out what the arithmetic sequence was. So given that it was x, y, and x plus y, it'll be 2, 4, and then 6. For the geometric progression, geometric sequence, it was x, y, and x multiplied by y, which would be 2, 4, and 8. So I now have my two sequences. The next part of the question then asked, find the difference between the sum of the first 8 terms of the arithmetic sequence and the sum of the first 8 terms of the geometric. Okay, so that was the arithmetic sequence. That's the geometric sequence. And I want to get the sum of the first 8. So I'll put down the S of n formula for an arithmetic sequence, and I sub in my values for a and d, and n is 8, and I'll get out 72. For the geometric sequence, I'll put down my S of n formula for a geometric sequence. A was 2, or was 2, and n will be 8, and you get out 510. They wanted the difference between those two figures, so the difference is 438. Question 9. There was an error in the book in the question, so it should have read as find the sum of the following infinite series, and they're all pluses. Okay, so that was the adjustment. So in order to get the sum of the geometric series, I'd need to know how many terms there are. Now, I know what the last term is, but I don't know how many terms that would have represented. Like, is that the 20th term? Is it the 100th term? So I need to find n first to see how many terms were actually in that sequence. So set up your T of n formula for a geometric sequence. Okay, a is your first term, common ratio is 2. They're doubling every time. Sub that in, that's your T of n formula. Let the T of n formula equal the last term to figure out what term number is that. So the first thing we need to do now is get rid of the 3. Divide across by 3, and you'll then get 16,384. I want to solve for n. N is an unknown power in my index, so I have to introduce logs. Because it's an equation, you can introduce any log base at all. The quickest base to introduce would be a base of 2. So I'll get the log with a base of 2 on both sides. Log 2 to the power of n minus 1 with a base of 2 will just leave you with n minus 1. And log 16,348 base 384 base 2 will give you 14. Bring over the minus 1 and add it on and you get 15. That now tells me that term 15 was 49,152. So I now know there are 15 terms in that sequence, and they said find the sum of that series. So that means find the sum of the 15 terms. So S of 15 is what we're getting next. Okay, so S of n formula from the log tables. A is 3, or is 2, and n was 15 for the first 15 terms. Sub it in and you should get out 98,301. Question 10. The sixth term of a geometric sequence is 16. Okay, so term 6 would be 16. Remember all the terms for geometric. A would be the first term, AR is the second term, AR squared is the third term, AR to the power 4 is the fifth term. AR to the power 5 then would be the sixth term. So AR to the power 5 equals 16. The third term is 2. So term 3, which would be AR squared, equals 2. Find the first term, that means find A, and find the common ratio, find R. So I've got two equations here, right? So if it's like simultaneous equations, but if you isolate one of the variables, either get A on its own or get R on its own, then you can sub one into the other. So it would be easier in this instance to get A on its own. So if I work with equation 2, or you could work with equation 1, it doesn't really matter, but I worked with equation 2, AR squared equal to 2, divide across by R squared to get A on its own, and then put a box around that. So I've now expressed A in terms of R, which means I can now sub my value for A back into the other equation. So AR to the power of 5. Right, so where you have an A, replace it with what you said A was. Okay, and all of that's equal to 16. Simplify. If you've got an R to the power of 5 up here and you've got an R to the power of 2 underneath, rules of indices, you could subtract the powers. And you'll get 2 times R cubed. Divide across by 2 next to get r cubed on its own. So r cubed would equal 8. And to undo a power of 3, get the cube root of both sides. Or you could put both sides to the power of 1/3 if you wanted to as well. The cube root of 8 is 2. So I've now found r. Now that I have found r, sub my value for r back into a. And you will get out that a is equal to 1/2. And that's all the question asked me to do. It said, find the first term and find the common ratio. A is the first term, so term 1 is 1/2, and the common ratio is 2. You could check if that's correct. Go and get term 6, and it should work out to be a 16. Go and get term 3, and it should work out to be a 2. So you'll know your values are correct. 13. The sum of the first n terms of a geometric series are as follows. Find the least value of n for which the sum would exceed 2.65. Okay, so first off, they've mentioned the sum. So I'm going to go and put down my S of n formula. Okay, so it said get the sum of the first n terms. So it's a geometric series. A is 2. Then get your common ratio. Term 2 divided by term 1. And your common ratio is 1/4. All right, put down your S of n formula and sub into it. So A is 2, R is 1/4. Tidying that up, 1 take away 1/4 would give you 3/4. 2 divided by 3/4 gives you 8/3. Okay. Also, you had 1/4 to the power of n. That means 1 to the power of n all over 4 to the power of n. But 1 to the power of anything remains as 1. And then 4 to the power of n is 4 to the power of n. So that's where I'm getting that out of. That's your S of n formula. I can't do any more with that bar multiplying out the brackets if you wanted to, but I'm not going to bother. Not yet. There'd be no reason to, because I'd end up having to work backwards in a second if I did. So that's your S of n formula. Right. The question said, though, find the least value of n for which the sum of that series exceeds. To exceed it means to be greater than it. So I'm going to let my S of n formula be greater than 2.65. And I set up my inequality. So that was my S of n formula. It is now greater, it exceeds 2.65. And I want to solve for n eventually. Get rid of the 8 over 3. So it's being multiplied here. So undo that by dividing by 8 over 3 on both sides. That will then leave you with the bracket on its own. 1 minus 1 over 4 to the power of n is now greater than. 2.65 divided by 8/3 is 0.99375. You could bring the minus 1 over 4 to the power of n onto the right-hand side, and it'll become plus 1 over 4 to the power of n, and you can bring the 0.99375 over onto the left, and it'll be minus 0.99375. 1 minus that gives you 0.00625, which is greater than 1 over 4 to the power of n. I don't like fractions, okay? So given that 4 to the power of n, it's definitely a positive number. So we're going to multiply both sides by 4 to the power of n. And when you multiply an inequality by a positive number, nothing affects the sign. The sign stays as it is. So that's grand. So I'll multiply both sides by 4 to the power of n. Okay. I will then get 4 to the power of n multiplied by 0.00625 is greater than 1. And then you want to get 4 to the power of n on your own, which is why I would then divide across by 0.00625, and then it will look like this. Okay, so I'm just missing that extra line of work there. That's all I did. I multiplied across by 4 to the power of n. And then after that, I divided across by 0.00625 to get this. Now, that 1 divided by 0.00625 works out to be 160. 4 to the power of n is greater than 160. There was no number that I could put 4 to the power of, or that I could put to the power of to give you back 160. So I can't use rules of indices. So then I introduce logs. Because it's an inequality, I have to introduce the natural log. Okay? So introduce ln on both sides. So it'll be ln 4 to the power of n is greater than ln 160. Then you apply your rules of logs after that. Okay, so I apply the rules of logs, get the ln of both sides. Apply your rules of logs, bring down the power in front. So it'll be n times ln 4 is greater than 160. I want to get n on its own, so divide across by ln 4 on both sides. But you need to check. You're now dividing an inequality by a particular number. If you put log 4, ln 4 into your calculator, it'll come back to be a positive answer. So then that's fine. I don't need to flip that sign around. Okay? That will now leave me with n is greater than, and I'll put 160 divided by ln 4 into the calculator. I'll get back 3.66, and it goes on forever. Now remember, n represented a term number, and the question asked, what is the least value of n for which the sum would exceed 2.65? So I want the least value that n could possibly be. Well, if n has to be greater than 3.66, n would have to be 4. and that would be the least value that n could possibly be. And you can check if that's correct by subbing n equal to 4 back into your S of n formula to see does it work out to be a number greater than 2.65.